All right, I think we're ready to start this party. Psst, hey,
All right, y'all ready?
guys,
We're ready.
we're ready to start.
Welcome to the Chadev+Python meetup. If you didn't get any pizza, make sure you come up here and get some before we get started here in a second. We've got pizza from Little Caesars and cookies and stuff. So I hope everybody saw the meetup invite to bring a laptop, hopefully. No? All right, next time bring your laptop. I'm trying to do something different, have people bring their laptop so we have a hands-on portion of the night so people get more involved. Yeah. So we did this last time and it worked out really well. I'm sure it'll work out really well tonight, and hopefully for the future, every Python meetup, bring your laptop, and we're going to have stuff for people to hack on. Hopefully, which tonight we have Steven here, and he's going to be giving a presentation on Scapy, and he's going to have a little demo, people to walk through, do some hands-on stuff with it. So we're going to do that tonight, and hopefully every night after this. So I'm going to hand it over to Steven.
All right, cool.
Yeah, this is.
Oh, me? I'm just Steven. I actually hold on a second. I'll pull up my intro if I can find it. Oh, I didn't even make one. It doesn't matter. I'm average security guy. I'm on Twitter. I do stuff with security related stuff. If you want to know about me, the best place to go is my GitHub account. Just average security guy on GitHub. All of the code, whoa, I sound so loud to myself. We're good? Okay. All right. All of the code and stuff that we're going to be playing with today and the PDF of the slide deck is available on GitHub. If you go to averagesecguy/Scapy, I've got all of the code that we're going to go through. I've got the slide deck. Make sure you read the README, because there's a couple of these scripts where you need to kind of set things up a certain way for them to run properly. First of all, how many of y'all have actually used Scapy before? Okay, 2 months ago, me neither. Basically, Justin said, "Hey, can you come do a presentation?" I said, "Sure." I said, "What on?" He said, "Scapy." I said, "Okay, I guess I better learn Scapy." So 2 months ago, I had no clue how to use Scapy, and so I've been playing around with it, learning it, putting all this stuff together, and I've figured out that there are some things that Scapy is not good for, and one of those things is trying to send packets from one machine to another service on the same machine. There's some issues there, so you have to set up some of these demo scripts. You need to set them up a certain way, and all of that's in the README. So when you pull this code down, make sure you look at the README. Some of them you won't have to do anything with, but you can just do git clone and grab that. If you want to fork it and throw some more scripts in there, feel free to fork it. Put more scripts in there. If you want to create issues or anything like that, feel free to just throw some issues up there, and I'll try to fix whatever I can. The plan tonight is to quickly go through a slide deck, and once we get through the slide deck, do some coding. There will be some code kind of along the way as we go, but anyway, intro to Scapy. All your packets belong to us. The easiest way to get Scapy is to see if your favorite Linux distro has it in the package repository. I just basically set up a VM with Debian 7. I set up a Debian 7 VM, did an apt-get install Scapy. It put a recent version of Scapy on there, I think 2.1 or 2.21. I don't remember. It's not the latest version, but it's darn close. You can also go straight to secdev.org and pull down the source code, compile Scapy yourself, all that kind of good stuff. But the easiest thing to do is to, whatever Linux distro you use, just see if you can do a yum install or an apt-get install. I'm a Debian person, so that'll be the last time you see Yum or anything like that. Okay, pcaps. If you want to get some pcap files to play with Scapy, there's a lot of good places to get some. There's a dns.pcap file that's in the Scapy repository on my GitHub account, and I actually pulled it off of the Wireshark sample captures here. So if you go to these 3 resources here, there's a ton of pcap files you can pull down and process them with Scapy, pull data out, all the kind of stuff we're going to be demonstrating tonight. So if you want some good Scapy tutorials, here are some beautiful tutorials that you can pull up at your leisure, and feel free to just run through them, play around with them. And they will go into a lot more detail. We're just going to scratch the surface of Scapy tonight. Scapy is huge. It is a huge project. And there's a lot of stuff you can do with it. So we're just going to be scratching the surface tonight. Please go to the tutorials and learn some more stuff. All right, so there's 3 different ways to use Scapy. The first way is you can run, once Scapy is installed, you can actually run the Scapy command, okay? Have any of y'all ever used the interactive Python interpreter? You just type Python at the command prompt, you get the little, 3 arrows. Okay, Scapy has the same kind of thing. You type in Scapy, you get a Scapy prompt, and then you can just, screw around with Scapy that way, okay? The other way you can do it is to type in Python and get the Python interpreter, the interactive interpreter, and import Scapy, and then use Scapy from there. I like to use scripts. I'm partial to scripts, so we're going to be using scripts throughout all of this. And then, with the scripts, it's a lot easier to stick a script up on GitHub and modify it and maintain it over time. So, all right, so creating packets. Are all y'all familiar with the OSI model, or basically how packets work? Okay, you got Ethernet. Well, first of all, nobody uses the OSI model. It's a reference model. What you use every day is more of the Linux, Unix kind of model, which is Ethernet, IP, TCP or UDP, and then some protocol on top of that. Okay, and so when you're building packets in Scapy, that's how you're building it. Okay, you're building Ethernet, then the IP, then either the TCP, UDP, or the application or whatever. Okay, you're building it up as you go along, and you use the / operator to join the groups of packets together. Now, if you just skip, like let's say we skip Ethernet, then Scapy will put that in for us. Okay, it'll actually kind of assume that we needed an Ethernet packet to stick our IP packet in, or Ethernet frame to stick our IP packet in. Okay, so let's take a look real quick at create packet. I'm going to go over here, my Linux distro here, and all you Vim people can just deal with it. I like my Nano, okay? We're just done. All right. So the first couple lines in all of the scripts that you see are just there to basically kill off a warning about IPv6. When you run the script, if these first 3 lines weren't in here, the fact that it can't find an IPv6 address on my VM, it throws an error, throws a warning message. So I just skip all that crap so it doesn't show. This is really where our Scapy script begins. Okay, so we're going to import everything from scapy.all. We're going to import star, and that's going to bring in all of our stuff we want to use with Scapy. Okay, and then we're going to build up some packets. The first thing we're going to do is create an Ethernet frame. Okay, and we can specify everything we want to specify about that Ethernet frame. We can specify the source MAC, the destination MAC. We can specify whatever we want about that Ethernet frame. and then we can print out that Ethernet frame, and I'm actually, in this case, I'm using the representation repr to show you the packet. I'll show you a couple other ways to print out packets later. But we can print out this Ethernet packet and or Ethernet frame, and you can see what it is. Okay, see what it looks like. All right, so the next thing we're going to do is we're actually going to tag an IP payload onto that Ethernet frame. Okay, so we use the slash operator. All right, and then we create an IP packet, and we tell it what server we want to go to, and that's going to be google.com up here. Okay, I just set it to Google. And then we can set up, on our TCP, we can set up what port we want to go to. You know, we can set source port, destination port. On IP, we can set time, or TCP, we can set time to live, things of that nature. We can set all of these different features or different, good night, my brain won't work today. We can set all the different settings for each of the packets and each of the layers, okay? All right, and then finally we can actually set, on top of this TCP packet that we've built, we can actually put in a raw payload if we want. So in this case, I'm actually doing a GET request for index.html, HTTP 1.0, you know, so this is basically the first piece of data you would send to a web server to get a response back, okay? Now we can also build all this stuff up, instead of building it one bit at a time, like we did here, packet, then IP, then TCP, then finally the HTTP, we can actually build it all up at one time in one line, okay? And like I said earlier, if we skip out and do something like that, we just don't do ether, Scapy will assume the ether part and give us a Ethernet frame to stick all that in, okay? Run this thing. If you don't give it, okay. Well, okay, first of all, here's the Ethernet frame and the source that the source MAC we actually told it to do. And then we add the IP with google.com as our server. And then on top of that, we added the destination port for HTTP. And then we added our raw payload. Okay, so you can see that stuff being built up. Here, we didn't specify, when we built it the second time, we didn't specify a source frame or anything, a source MAC. And so it uses the MAC of the machine. Okay, so if you don't specify the IP address, the source IP, or the source port, or anything like that, it uses, you know, default values. So for the source, for the MAC, it'll use the source MAC of whatever interface you tell it you want to send the packet out on. It'll use the source IP of whatever interface you tell it to send the packet out on. For the port, the source port, it seems to default to FTP data. Port 20, forget it, I don't remember. FTP data, okay, it defaults to that port. A lot of people will put code in their Scapy scripts to grab a random port from 1024 up to 65535. They'll just stick a little, you know, random dot whatever and grab a random port. I don't really care at this point. Okay, but you can see how we've created the packets, either layer upon layer or doing all the layers at one time. Okay, that's the basics. There's no need to specify explicitly the source port, but you do need to specify the destination port of whatever you're trying to reach. But there's no reason to specify the source port, because it'll put one in there for you. All right, so processing a pcap. So one of the things that Scapy will let us do is it will let us read in a pcap file and then let us process that pcap file, okay? So we can go through the pcap and we can pull all of the packets out of it. We can get a summary of all the packets. We can pull out you know, for each packet, we can find out what its source MAC, destination MAC, IP, port, all that stuff. We can build a bunch of stats off of that pcap file. And for me as a pen tester, what I learned from taking time to learn Scapy is that I will probably never use this as a pen tester. But if I'm doing packet analysis, Scapy is my friend. Okay, just the stuff that you can do with it, it's pretty awesome. Okay, so packets again are built up from the Ethernet frame. Ethernet frame has a payload. IP packet has a payload, and then the TCP, UDP packet, they have a payload. Okay, and we'll look at that payload. Right now, we're gonna go look at process. Okay, and again, same 3 lines just to suppress the warning. This is where our script actually begins. Okay, and so we're going to get a list of packets by reading this pcap, rd pcap, okay, scapy.all.rd pcap, and then I give it the DNS cap file that's actually in the data folder in the GitHub repository, okay. Whatever path you want to give it, it doesn't matter, just, you know, whatever pcap file you want to give it. Okay, so we can just do a 4 packet in packets. We can just look through, because it gives us a list of packets or an iterator. We can look through each of the packets, okay? So here, all I'm doing is I'm grabbing the packet source and destination. This is the MAC address source, MAC address destination, okay? And then if the whole packet right here, packet in packets, that's the whole Ethernet frame, okay? I can get the IP portion of it by taking the payload of packet, okay? So you got the Ethernet packet or Ethernet frame. Good night, I'm gonna kill myself. You got the Ethernet frame and it's got a payload, okay? And that payload is the IP datagram or the IP packet, okay? So we can grab that by using the payload command, and then we can go and get the IP source and the IP destination, and that's going to give us the source and destination IP addresses, okay? And then we can actually look at the protocol, okay? And protocol 17 is, anybody? It's UDP, right? Or am I backwards? It's UDP, okay. Protocol 17 is UDP, so I can go and get the UDP source port, UDP destination port. Protocol 6 is TCP. I can go get the source port, the destination port. If you're looking through a bunch of packets and you need to get ICMP, ICMP has a different protocol number. You just find that protocol number, you're good to go, okay? So this is one method of processing pcap files. Okay, we can take it apart, payload by payload, okay? And so what we're going to do, we're going to run this thing. All right. So you can see it went through the DNS capture. It got the source MAC, the destination MAC, source IP, destination IP, UDP, source port, UDP, destination port, okay? It went through and grabbed all of that out of that pcap file, okay? Now there's another way we can process pcaps. And it's a lot easier. We can actually go and grab the IP payload just by specifying IP, okay? It's kind of like a dictionary, all right? If you look at it like a dictionary, the packet has an IP key, and it has the IP payload in there. You can grab that, and then you can get the source and destination off of that. You can grab UDP packets by saying UDP. You can grab TCP packets by specifying TCP, okay? You could do ICMP as well and get ICMP packets, all right? So it's the same basic concept, but instead of breaking it down payload by payload, we just go and grab the specific piece that we want, okay? And so we'll run this. Apologize, I can't type while people are watching me. All right. So in this case, we've done the output a little bit different. It's a UDP packet, source IP, source port, destination port. Okay. We've just printed it out a little bit different. All right. But we're still processing that same pcap file, that same DNS pcap file. Is this making sense so far? Nothing. Yeah, I mean, you can use Scapy similar to the way you use Wireshark. So you can process a pcap file, like you can load a pcap file in Wireshark, and you can filter and you can do all that kind of good stuff. But with Scapy, you can actually write scripts to take some of that data, do something else with it, resend a packet. You know, just lots of different things that you can't necessarily do with Wireshark, or at least not that I know of. As far as I know, you can't replay packets with Wireshark, or can you? I haven't used Wireshark in a while, but okay. All right, so we processed a pcap, processed it a couple of ways. We can also sniff traffic with Scapy, okay? Here's a couple of different articles on doing some sniffing with Scapy, okay? There is one thing you need to know about Scapy as far as sniffing and sending packets and all of that stuff. Scapy operates at the user layer, not the kernel layer. So there's times when you're doing things in user land with Scapy and the kernel will see that you're doing something and it'll screw with you because the kernel didn't make that packet, you know, or the kernel didn't do, you know, like you'll send a packet and the kernel says, I have no idea what packet that is, and issues a reset because the kernel didn't issue the original packet. You know, you send out a send, get a send act, kernel's like, screw that, reset, because I didn't send that. So remember, Scapy operates in user land, and the kernel operates, or the normal, your normal networking operates at the kernel level. All right, so let's take a look at sniff.dns or Sniff DNS real quick. Kind of fun. All right, so what we're going to do, same 3 lines. Right here, we're setting up a filter, okay, and it's literally a text filter, okay. We're saying UDP port 53. So we're gonna start the sniffer a little bit further down here, and we're gonna tell it to use the filter that we created, and the filter is just UDP port 53. Okay, we can specify an IP address if we want to. We can specify TCP. We can specify UDP. You could specify MAC address, whatever. So there's multiple ways you can filter while you're sniffing. Okay, so we're sniffing DNS, so we're gonna set up our filter to use UDP port 53, all right? Now, when we sniff a packet, we have this little PRN method that's on the sniff. There's a PRN parameter to the sniff method, and that is a function, okay? You just pass it a function, all right? And whatever function you pass it, when it sniffs a packet, it's gonna send that packet to that function. Okay, so if we go up here to process DNS is expecting a packet. Okay, so every time a packet comes through, every time it sniffs a packet that meets the filter, okay, it's going to send that packet to our process DNS function, and then we can do whatever it is we want to do with that packet. Okay, make sense? Okay. All right, so what we're actually doing is we're going to look and see, or take this DNS packet here. We're going to pull out the DNS portion of it. Okay, we got a packet. We're going to pull out the DNS portion of it, and then we're going to actually look and see if it's a query. Okay, there's a parameter on the DNS packet called QR, and if QR is set to 0, then that means this is a query. Okay, if it's set to 1, it means it's not a query. I think that's the way it goes. DNS is freaky, so if you ever read the DNS protocol and try to figure all this crap out, it's a little freaky. This was one of the harder scripts for me to write, just trying to figure out DNS. But anyway, so we can pull out the queries, we can find the queries, and so we can actually spit out what kind of query it is. Is it an MX record? Are we looking, it'll tell us the type of query we're doing. Are we looking for a start of authority? Are we doing an MX? Are we doing a name, C name, whatever? Okay, we can pull out the query type. And then we can pull out the name, Q name. We can pull that out, what we're actually looking for. Okay, so this is the name of what we're looking for, and this is the record type we're looking for. All right. If QR is 1, then that means we've got an answer of some sort. Okay. AN means that we have an actual answer to an A record or a C name record or something like that. NS means we've got a name server that came back. And then AR, I actually do not remember what AR stands for right now. Like I said, DNS is a little freaky. Okay, so basically what we're going to do is, now that we've gotten, so if we get a query, we spit out, here's my request. Okay, this is what I'm looking for, the name and the type of query I'm looking for. Okay, and then if we get a response, if the packet's an actual response, we'll look and see what kind of answer we got back, and so we'll spit out the name, the resource record name, and then we'll spit out whatever data came with it, okay? And so we can see the response from DNS, okay? All right, so let me try to run this thing. And again, I'm telling you, DNS is a little weird. You probably noticed a couple of lines in there that I didn't explain. I'll try to explain them afterwards if you really want to know. But for the moment, I can't do that. So we're going to do sudo python sniff fit. I have a fear of typing. All right, so we're going to sniff DNS. All right, now we're going to go over here and do dig google.com. All right, and you can see that over here, we picked up a request for an A record. Okay, we sniffed a request for an A record, and then we got multiple responses with the actual IP address. This is the name we were searching for. This is the IP address that came back. Okay. If we come over here, and hopefully this is going to work for me. Nope. All right, like I said, DNS is a little freaky. So I see the request, and I got a start of authority. I'm requesting a start of authority record, but something in the way I'm processing the response is not working out quite right, and so my response for the start of authority record is not right. That response coming back is not right. We can do X, and again, you can see the request is for the MX record, and then I'm getting some odd responses. That one actually comes back right. So I'm telling you, DNS, weird stuff. Feel free to play with it. If you look at the slide, let me pull the slide deck back up. This guy right here. Both of these are some good tutorials on DNS itself, like the DNS protocol and what the AR and the QR record and all that stuff means. If you're really interested in playing around with DNS, read those things. They're quite helpful, okay? Okay, so now we're going to do some work on some sending of packets and some sending and receiving of packets. There are two commands for sending packets, send and send-p, okay? Send expects a layer 3 packet, so you're an IP packet, all right? And send-p expects a layer 2 packet or a packet set, okay? And I'll show you what I mean by packet set in a minute. So send and send-p are used, and we'll take a, but notice that they don't wait for an answer, okay? They just send the packet. They don't wait for an answer. We'll get to answers in a minute. So let's take a look at send.py. Okay. All right, so we've got a server, and actually I need to modify these or else we're going to be in trouble. I am This is part of the, if you look in the README where I was talking about the setup, I have some info in there on how to do, or what you need to set for server and server 2. Basically what you're doing is setting server to whatever machine the Scapy script is running from. You're setting that IP address, and then server 2 is going to be any other IP address that you have control over. And that you can send packets to, okay? All right, so we've got our server, we've got our port. What we're gonna do is build an Ethernet packet. We use Ether, we set IP to be the server. The destination is gonna be server. This should be server. All right, destination is gonna be server 2. And the D port, destination port, is going to be port 8000. We're going to print out the packet using summary. So each packet has a method on it called summary that'll print out a summary of the packet. This is a good way to see the basics of what the packet is. There's another function called show that we can use later on, and it'll give you details about the packet layer by layer. And that's a good one to look at too. So we're going to send P this Ethernet packet because we built it up from Ethernet, okay? And then we do the same thing. We're going to do IP, and we're going to send an IP packet, but we'll use send instead of send P, okay? Does that make sense? Actually, okay. You can see that Scapy says the packets were sent, but we don't see them in, oh, yeah, we do, I'm sorry, not paying attention. You can see them here in PCP dump as well, okay? Notice that it picked up, by default, it picked up the source port FTP data whatever reason, it defaults to that port. Okay, it's actually showing our other server as showing this server as the source, the other server as the source. Then we're going to, oh, I typed in the address wrong, that's why. Okay. So we're picking up our source address here, and then we've got our destination address, which was server 2, and you can see that it set the send flag, because that's the first packet that always gets sent out is a send flag. Okay, does that make sense? So we're just doing a basic send. We're not waiting for a response. We're not doing anything like that, okay? The next, I ain't gonna pull the slide deck back up because it doesn't make any sense to do that. Okay, so the next thing we're gonna look at is we're gonna look at the SR and SRP, okay? So here's SR, and that stands for send receive, and then there's an SRP, which is send receive as well, and it's the same difference. You have IP and Ethernet, okay? So if you've got an IP packet like this, okay, then you use SR to send it. If you've got an Ethernet frame, you use SRP to send it, okay? Now, SR is going to receive back 2 lists, okay? It's going to receive back 2 lists of packets. One is going to be the list of packets that were answered, and one's going to be the list of packets that were unanswered, okay? So what we've got up here, we're actually setting our port to a range, 8,000 to 8,002. So 8,000, 8,001, 8,002, okay? So we can actually set our destination port to a port range using the tuple format, okay? You can actually set your server doing the same thing. You can set a range on your servers too, okay? So what we're gonna do, and I've got the timeout set to 5 because otherwise we'd be sitting here waiting and waiting and waiting for a while. But I got the timeout set to 5 seconds. So basically we're gonna send our packet that we created. We're actually gonna be sending out 3 packets, 1 to each of the 3 ports that are on the list, and we're gonna be waiting for an answer, okay? Now, if there's something listening on one of those ports, we should get an answer back. If there's not, then we won't get an answer, okay? So let me go fix this real quick. Okay, so now right now, I've got nothing on this server on 101.162 listening on port 8,000, 8,001, or 8,002. Okay, so we're sending 3 packets, and I'm waiting, okay? And you can see that none of them got an answer, all right? And all 3 of them came back unanswered, all right? There's some settings in Scapy. If you go and look at the other tutorials, there's some settings in Scapy that'll let you tell it how long to wait. If you want it to just keep trying and trying and trying, how many times you want it to retry, that kind of stuff, okay? So now let me set something up over here. Try this again, and what we should see this time is we should get 1 answered packet. Okay. So we got 1 answered packet. We sent a send. We got a SYNAC back. Okay. So we've got 1 answered packet and then 2 unanswered packets. All right, because we actually had something listening this time on that server. Does that make sense? Okay. Moving right along. All right, now here comes the fun part. All right, so now we've got another function we've got SRP1 and we've got SR1, okay? We're using SRP this time instead of SR. But we've got SRP1 and SR1, and those send out a packet, but they only receive one packet back. They don't give you a list of the answered and unanswered packet. You just get the one packet back. If there's no answer, you get none, okay? You get the Python none back, all right? And so what we're actually going to do with this is we are going to give it a server and a port. We're going to give this handshake function a server and a port, and we're going to attempt to go through the entire three-way handshake, okay, the TCP three-way handshake. So the first thing we're going to do is we're going to build an IP packet with ether, use ether, and then the destination of whatever server we give it, and in this case we're giving it google.com, okay? And so we're going to set the server, the destination to be google.com. We're going to set the port to be port 80, and we're going to set the send flag, okay? And then we're going to print out that packet here using the summary, and then we're going to send that packet, okay? So we build the packet up together, IP, TCP. We're going to build that packet up, and what the response back to us should be is a SYNAC packet, okay? Google should send us a SYNAC as a response, okay? Now, when we get that SYNAC, we can actually go back and create our next packet, okay? And the way our next packet has to be built is we have to use the destination port from the answer as the source port for our response, because you know we're swapping the ports on this. So we're going to set the D port from the SYNAC packet. We're going to set that to the source. The source port from the SYNAC packet, we're going to set that to the destination. We're going to set the flag A. We're going to set our ACK flag. Okay? And then the way TCP keeps up with where it's at in the stream is it has a sequence and an ACK number. Okay? So when we send out the first send packet, the sequence number is 1. Okay? When we get our send ACK back, it's going to increase the sequence number by 1, okay? And then we actually have to put that sequence, so we grab the ACK value from the SYNAC, put it into the sequence, that's the new sequence, and then we add 1 to make our next ACK number. So that's how TCP keeps up with what packets it's done, all right? And then we're going to print the summary again, and then what we should get this time when we send this packet is we should get back from Google, I believe we're going to get back a reset in this case. We're going to get a reset because we're not sending any other data, okay? All right, so we're basically going through the three-way handshake. We're doing a send, we get a SYNAC back, and then we send an ACK to complete the handshake, okay? And then since we don't send anything else, it's going to respond back to us with a reset, okay? That's the expectation. All right, so we built our SYN going 101.163, which is our server, out to Google. We're going to the HTTP port, SYN flag. We sent it, we received 1 answer back, okay, and it was a SYNAC packet. You can see Google responded from HTTP back to us with the SYNAC, okay? Then we take and build our ACK. We go back to Google with an ACK. Screwed up. Anyway, we go back to Google with an ACK. We get an answer, and that answer is a reset from Google, okay? So we went through the full three-way handshake, TCP three-way handshake, 1 packet at a time, all right? So you can get down and dirty with Scapy here. Let me pull this back up real quick because I want to show you Send and receive. The folks over at Sands, they have a nice little diary entry about how to do some fuzzing with Scapy. And one of the problems with Scapy is if you want to do real fuzzing with it, you have to manage that whole synac, all the, you got to go through the three-way handshake every time, right? So this diary entry actually talks about how to use a Python socket to build your connection to your server that you're wanting to fuzz. So you build a Python socket, and then you give that socket to Scapy, and then after that, you can just send stuff with Scapy through that socket. So the kernel itself is using, the Python code is using the kernel TCP/IP stack to build the connection, and then you're just sending data back and forth with Scapy. So if you actually want to do some fuzzing with Scapy and just send crazy packets to some SCADA or something, whatever, then you would want to follow through these directions here and actually use the Python socket. Okay. All right. So there's the send receive that we did. There's the handshake. Last thing we're going to do is we're going to rewrite some packets on the fly. We're going to sniff and rewrite. Okay. And we're just going to see how that goes. All right, Nano. All right, so what we got here, old server is actually going to be the box we're sitting on. So that's 10 dot. Server is going to be okay. All right, and then we've got our old port and our new port timeout. We're going to filter on TCP. Okay, so we're going to sniff. We've already told it what the filter is going to be, all the TCP packets. Okay, so I want you to pick up any TCP packet that comes in. We could actually modify the filter some, and that would keep us from having to do certain things we're doing here in the rewrite, but it doesn't matter. So what we're basically going to do is sniff for all TCP packets, and then if we find a TCP packet, we're going to send it to the rewrite function. Okay. Now the rewrite function is going to look at the IP destination and see if it matches old server, and it's going to look at the TCP port and see if it matches old port. And if it does, it's going to modify the packet. Okay, it's going to overwrite it's going to overwrite the destination with the new server, okay? And it's going to overwrite the destination port with the new port, okay? And then it's going to actually try to send that packet out. All right, does that make sense? All right, so here, this is what should happen, Lord willing. What we're going to do, we're going to set up over here, NC minus L minus P 8000. What I'm going to attempt to do, and hopefully you'll be able to see what's going on, I'm going to attempt to NC minus okay. I'm still having trouble getting this thing to finish. But basically what you can see, I'm not doing the full three-way handshake on this, but what you should be able to see is I pulled in a packet from 163 destined to 163 port 8000, okay? I rewrote that packet so that it goes from 163 to 162 on port 8888, okay? And so I get my SYN. And then from 163, 52, 333, I get my 8000 back, and it gets rewritten to 8888. And actually, it never actually makes it over here, because again, I told you Scapy sits at the user land level, and the kernel is actually interfering with being able to take that packet and actually send it over here to 8888. But you can actually see that I was able to sniff the packet and then rewrite parts of the packet. Okay, so you can see the original packet that came in, and you can see the new packet that actually went back out. Okay, and let me make sure I didn't screw something up when I made that change a second ago, because I thought I had this. But you can see that the packet, even though it didn't turn out quite like I wanted it to, you can see that the actual packet was rewritten and sent. There it is. So 52, 236 was going to 8000, and then we sent a packet to 8888. And if you look over here, you can see that that packet actually, that SYN packet actually came over to this server. Since we're not doing the three-way handshake, we're not completing the connection, and you're not seeing anything written out down here, but you can see in TCP dump that the packet actually made it. Okay, does that make sense? So we're able to sniff and then rewrite the packet on the fly. Okay, that is pretty much it. That's the whole presentation. If y'all want to sit and chill and go through some of these code samples, if you want to ask questions about the code samples, feel free. If you want me to modify any of these things and play around with them, we can do it up on screen, you know, whatever. I'm open to whatever. Do what? Thank you, I appreciate it. And please do, like I said, fork the GitHub repo. If you want to make changes, make changes, send in issues. You want to add some of your own scripts or whatever, I'll try to keep up and try to keep putting them in there as you guys do that. So have at it.
Sweet.
Thank you.
Awesome. That was pretty cool.